Hello, welcome back to my channel. So today let's talk about the chi-square test. So I'll pose a question before I go any further. So is there a relationship between two categorical variables? Or maybe is gender related to smoking status? Is education level related to type of employment? Well, that is what the chi-square test tries to illustrate. So the chi-square test is a statistical test that determines whether an association exists between two categorical variables. Okay, so in my last video, in my last session, I talked about categorical variables. Okay, so that includes, that is qualitative data. So it is also called the chi-square test of association. Okay, so if you wanna discover the association between two categorical variables, and then the chi-square test is ideal. So quickly, what are some of the uses of the chi-square test? Okay, so some of the uses of the chi-square test, they can include maybe in market and research and business. You can test if there is an association between the customer age groups and the preferred product types. You can also determine if smoking status is associated with lung disease prevalence, that is in healthcare and medicine. Okay, then in education, I've also given another example. You can evaluate if different teaching methods result in different levels of student success. So that is all about the chi-square test. It is a statistical test that is used to determine or investigate an association between two categorical variables. Okay, so quickly, I will not go back, I will not go deep into the mathematics, but um, let me quickly show you something. Okay, all right, so I'll quickly show you something. So let me just grab my screen here. So let me get a white screen. Let me just get maybe a highlighter. All right, okay. So what I want to understand is that what I want you to understand is that mathematically the test statistics, okay, the formula will be represented by x squared, okay, x squared equals, okay, assume that's an equal sign, and that is the summation symbol, okay, and then you have okay, you have what is known as the observed, what is called the observed minus the expected, okay, close that, and everything also um, over the expected, okay, count. Okay, so this is the formula. Okay, this is the logic behind the chi-square test. So the x squared is the test statistics, and then the observed, and then we have the expected. Okay, but what exactly is the observed and the expected? Okay, and what is the what is the logic? What are we trying to establish here? So what we are trying to establish here is very straightforward. Okay, so we have let me start with the observed. Okay, so we will be using SPSS to illustrate to perform the chi-square statistics. So I've brought this formula so that at least you have a foundation, or you have an understanding of what is happening in SPSS. Okay, so we have the observed, which is represented there with O. So the observed is actually what you saw in reality, is what you actually measured, what you have. Okay, and the expected is actually, the expected frequency is what you expect to see if there was no relationship. Okay, and then this is the test statistic. So the logic is that if the difference between the observed and the expected frequency is big, then the chi-square test, or the chi-square value grows very large. So which suggests more evidence of a relationship. I'll go again. So you have the observed and the expected. So the observed, it's the what you saw or what you actually measured, and then the expected frequency is what you expect to see, what you would expect to see if there was no relationship. So the logic or the connection is that if the difference between the observed and the expected is big, then the chi-square value grows very large. And as the chi-square grows very large, then that is more evidence of a relationship. Okay, so that is the mathematical side. So I won't be going deep into how you can calculate the expected frequency. Okay, but from a 2 by 2 table, the expected frequency can be calculated as E. Okay, an equal sign may be here. Okay, then you do the row total. So you have the row. Okay, you have row total. I'll call it RT. So you have row total, and then you multiply it by the column total, which I'll call as C, which I'll name is at C, T, and then everything you are going to divide this by the grand total. Okay, the grand total. All right, so that is how you can calculate the expected frequency manually. So it's a row total, you multiply it by the column total, and then the grand total. That will be your expected frequency. But this time around, we won't be worrying much about this because we are going to use the SPSS software to do that. Okay, all right, quickly. Okay, so let's move to the hypothesis. So the chi-square test also has what is called the null hypothesis. Okay, I'll call it the HO, okay, and the H1. So H1 is the alternative hypothesis and HO is the null hypothesis. Okay, so what really does the null hypothesis state? Okay, so the null hypothesis will state that in this case, if we are looking at maybe if our question is there a relationship between gender and smoking? So the null hypothesis will simply say there is no relationship, no relationship, okay? And then the alternative hypothesis will say otherwise there is a relationship, okay? Now, how do we reach to a decision? How do we decide now whether to reject or to fail to reject the null hypothesis? This is very much critical in this case. So we have what will be produced in the software. It's there will be a p-value, okay, but this p-value will be represented will be labeled as the asymptotic significant, which is also like the p-value. So this one is what will determine whether you reject the null hypothesis or fail to reject the null hypothesis. Remember, the null hypothesis states that there is no association between gender and smoking, and the alternative hypothesis will say there is an association. So the decision depends on the p-value. Okay, so the p-value or the asymptotic significant is the key result in this case. Now listen to this. If your p-value, okay, if you say p-value is less than, so if your p-value is less than what is called as the 0 point, okay, 0 0.05, then that would mean, okay, that would mean there is significant relationship that exists between smoking and gender in this case. Okay, then if the p-value is greater than or equal to 0.05, then we fail to reject the null hypothesis, which in other terms mean there is no significant relationship between gender and smoking. Okay, so it's important to note that when reporting your results from the chi-square test, please do report the Pearson chi-square, row, which has the test statistic, and you can also do the degrees of freedom, and then you also report the p-value. So quickly, let me show you, let me demonstrate, okay, using SPSS, how we can actually run that test. So quickly, let me go back to my SPSS. It's already open. So remember to import data in SPSS. You simply go on File, then File, then navigate to Open, then click Data. Okay, this box will appear. So my folder which has the file that I want is in this folder, which is Gabri. So remember, it's an Excel file that I'm trying to import. So right now you can't see anything. in this folder. It's like there's nothing, there's no Excel file. This is because the file type which is selected is the SPSS statistics.sav file. So you have to change this to the Excel extension, and then there you go, you see all the Excel files that are in this folder. So the sample data set that I need is a sample data set. By the way, you can find this sample data set on the Kent University website. Okay, and then click OK. Click open, sorry, to open that, and all you have to do is click OK. All right, and give it a little bit of time to load. Okay, so this is now my data set. So now the main question that I want to ask is, I want to understand if there is a relationship between gender and smoking. Okay, I want to understand if there is a relationship between gender and smoking. So I have this gender column, which is represented as 0 and 1. So 0 in this case would mean this is a female, and in 1 will mean this is a male. Okay, this is the male gender. Okay, so this is just for data grouping. There's nothing special about the 0 and the 1. Remember the measurement scale when we talked of the nominal scale. This is what is happening here. Okay, so let me go again to my smoking column. So the smoking column, I have 0. So, and in the smoking column, I have 3 possible outcomes. So I have 0, which means someone is a non-smoker. Then I have also 1, which means someone is a past smoker. Okay, then I also have 2, which will mean someone is a current smoker. And so SPSS, you see here, they are more replaced with dots. So here where you see dots, that means these are missing values. So I won't deal with missing values right now. I'll just go to the analysis. So I'll go on analyze, then descriptive statistics, then I'll navigate to descriptive statistics, then navigate to the crosstabs. So crosstabs, okay, here is your crosstab. Then I'll get my gender, and I'll throw it in the columns box. Then I'll get my smoking variable, and I'll put it there. Then I'll click on the statistics. Okay, remember to click on the statistics. So as you can see, the chi-square test is not checked. So if you don't check this, that means you want to run the chi-square test. Then I'll just mark this. These are also different kinds of statistical tests that we'll not talk about now. So I'll click continue. Then I'll go on the sales, and then I'll just remember what I explained, the observed and the expected. And so what I have to do is I'll check the expected also. Then I'll click continue, and then I'll click OK. All right. Okay, so now I have my output generated. Okay, so I can see 0, 1, 2, 3. Okay, so the first table is called the case processing summary. Okay, this is just an overview. I have 408 in total as my sample, which represents 92.4. Sorry, I have valid 402 cases, and then I also have the missing part. So it means 33 in this data set of mine, they are missing, which represents a 7.6%. Now, coming back to the cross tabulation of smoking and gender. So if you look at smoking, it has 3 categories, 0, 1, 2, 0, 1, 2. So we said 0 is a non-smoker, and 1 is a past smoker, and 2 is a current smoker. So what it means is that 0, which means non-smoker, we have how many? 149. Okay, sorry, let me go again. So smoking has 0, 1, 2, 3, 0, 1, 2, as I explained. Then we also have gender, which has 0 and 1. So 0 would mean a female, and 1 would mean male. So what it means in this case is that I have these guys who are non-smokers in this case, I have 149. So I have 149 females who are non-smokers. Okay, and the expected count, what I expect to see is 142.6. Okay, then I have 148 male who are non-smokers. Okay, and that is the total, and that is the expected count, okay, that I expect to see. And then I have past smokers, female. There are how many? 13. 13 past smokers who are female, and that is the expected count. Okay, and then I have also 24 are past smokers, male. 24 males who are past smokers. Then the current smokers, which is represented by 2. I have 31 females who are current smokers, and I have 37 males who are current smokers. Okay, all right, and this is the count and everything, the total. Now we go to the chi-square test. Okay, so this is actually where the big deal is. So the decision and conclusions. So how do we conclude now? So you look in the Pearson chi-square row, okay? You see where here it says value DF asymptotic as significant, which is two-sided. Okay, so in the Pearson chi-square row, this value that you see written value, this is the test statistic, okay? And then this is the degrees of freedom, and this is the p-value that we have been talking about. Okay, so in this case, we can see that our p-value is 0.205, okay, which is way greater than our our significance level. Remember, our significance level in this case is 0.05. So this p-value is greater than 0.05. Then how do we conclude? Okay, then we conclude there is no association between gender and smoking. But then how do we report our results? So you can say there was no association was found between gender and smoking behavior. Then in brackets, you report x squared. Remember, this is the x squared in that formula. So this is the test statistics, and also report the degrees of freedom. And then lastly, report your p-value. So that means in this case, there was no association between gender and the smoking behavior. Okay, so quickly before I go, let me just give you some tricks. So if you see, this is 0, 1, 2. So in case if this confuses you and you want something which is more of an illustration, so you can go back to your data set, then go to the variable view. Okay, then go on the smoking variable, okay, and click on the values. So on the values, what I'll put is the value is 0. So if the value is 0, that will represent someone is a non-smoker. They have never smoked in their lives. So I'll click non-smoker, then I'll click add. Okay, I'll go back again, 1. What did we say 1 is? So I click 1. What did we say 1 is? Then 1 would mean this guy is a past smoker. Okay, meaning they used to smoke in the past. They used to smoke, I mean. So click add. Then we have 2 here. Okay, 2, which would mean this guy is a current smoker. Okay, so this guy is a current smoker. Okay, so let me click add as well and click OK. Okay, so let me just go back to my analyze tab and go on descriptive stats. Okay, descriptive statistics, cross tabs. Okay, everything is there. Do I need to reset it or no? Let me just run this. Let me check if the chi-square test is marked. Yes, checked. And then I click just OK. Right. Okay. So let me this time around also let me also add clustered bar charts in this case, and then let me click OK. Right. And there you are. So you see now that there's a difference. Instead of representing this as 0, 1, 2, I now have non-smoker, past smoker, and current smoker. Okay, so that at least it gives me, so that everyone who sees this table, they are not confused of what 0, what 1, and what 2 actually is. So you can also do the same for gender, okay? By in the value section, the same way you did, you can put 0 to mean female and 1 to mean male. So let me just go back to my clustered bar chart. Okay, so this is your clustered bar chart. So if you expect an association, you expect to see at least these bars should be different, in other words, but they look almost the same. Okay. All right. So the takeaway is the chi-square test, you report in the chi-square row, the test statistics, the degrees of freedom, and also the p-value. Remember, for the p-value, the decision is if p-value, okay, if your p-value is greater than 0.05, then you fail to reject the null hypothesis, which concludes to say there is no relationship. If your p-value is less than 0.05, then that means there is a relationship. Okay, you reject the null hypothesis. Thank you so much. For any questions, any clarity, you can drop them in the comment box.